So this is our house. It was built about 1935, and we've lived here since 1988. Since that time, we've done a number of remodels on it, 4 to be exact. And just with those remodels, as we've worked our way around the house, changing it, every time we did something, we tried to keep in mind the energy issues. Tighten up the shell and add more insulation. And then we've also, as we've gotten new appliances, new washer dryer or something like that, we've always tried to get real efficient Energy Star rated appliances. We purchased a new furnace at one point, and then we also just 3 years ago added a photovoltaic system that reduces the electricity that we pay for. So if we go inside, I kind of show some of the wall sections and things like that and see the specific types of things that we've done. So that's kind of interesting. That's the before. That was actually 1991 after we'd painted it. It was it was a pretty rough looking place. When we first bought it, no one would insure it because it looked so bad. Hi, Bowen. So inside, on the walls, you can see at the windows how the walls are really thick. They're about probably 8 or 9 inches from outside to inside. And so what we've done is, when we first bought the house, we blew in cellulose insulation into the 2x4 cavity. So that's worth about an R14 or so, R value, which is okay, but it's not a lot. So then when we got around to wanting to remodel this room and rewire it, and the ceiling was in very poor shape and the floor was too, we decided to add some more insulation on the inside of the house. And so we added 2 inches of expanded polystyrene, like the stuff that's in insulated disposable cups. And then an airspace with a nailer, and then sheetrock on top of that. And all of that brings our R value up to about 25 in the walls. The other thing that's pretty important in the walls is the windows, are the windows. And so we have thermal pane glass, 2 panes of sealed glass with a low E coating on all the windows. And I think that's probably the most cost-effective, energy-efficient glass design. You can spend more money and you can get a triple pane, and you can get different gases injected in those windows, but it costs a lot more. Another thing is sealing up the envelope so that you reduce or try to eliminate the infiltration of outside air to the inside, so that you're controlling what's coming in and what's going out. And so kind of every step of the way we've tried to do that. And I'll show you the rim joists downstairs, where we actually used a foam to spray into the rim joist. That's a place where you usually get a lot of leakage, and I think it was a pretty good way of stopping that leakage and insulating at the same time. This is a picture of a wall section. So what it shows here is the outside stucco, the wood sheeting, exterior wood sheeting, the 2x4 space that's filled with cellulose, the press board and plaster that was the inside wall, and then the retrofit was this 2 inches of expanded polystyrene, an airspace that's got a nailer in it for nailing the sheetrock to, and then the sheetrock. So we've been at this for over 20 years, kind of trying to tighten the house up, and we try to do things that use less energy. I asked Northwestern Energy what the average use for the average house in their system was, and they said 750 kilowatts per month and 10 decatherms of natural gas per month. So this house uses about half of both of those. And then when you add the PV system, we're at about 25 or 30% of what the electricity usage is. So actually, let me back up. When you use the PV system, we're at about 15% of what the average house would use. Now we use more than that, but we pay for 15% because we're generating electricity from the photovoltaics. Just so we've tried to, well, one of the things we did a long time ago was bought one of these little gadgets. It's a load meter. You plug your appliance into the load meter and then plug the other end of the meter into your socket, and it'll tell you how much that appliance is using on an instantaneous basis. So you can get a sense of how much a light bulb uses versus a refrigerator versus the motor to your the fan on your furnace. And you can definitely create efficiencies in all of those places. And it's just a matter of kind of knowing where you're using that energy and finding ways to use less with more efficiency or turning it off. Downstairs, this is the basement. I don't know how well you'll see this, but so here's where we used foam to seal off that rim joist. If you come down here, we can turn on a light that's a little closer. You might be able to. There. So it gives you a pretty good sense of how well that seals and insulates. And then we wanted to kind of create a room, for the kids to play in, and we moved the TV down here, which gets it a little farther from everything else, which is okay. But also in this room, this is in the basement, so there's a 6-inch concrete foundation, but you can see how deep that window well is. So there's another 6 inches of insulation because there's another wall built inside of the concrete to provide more insulation. One of the things that I discovered with the load meter is that our old freezer was constantly going and it was using a lot of electricity. So for $450, we bought a new freezer, energy efficient one. Here's the Energy Star rating or tag, and I figured that just by spending the $450 on the freezer, we reduced our electricity bill by about a quarter. So pretty big reduction for just $450. Next I'll show you the PV system, which was a much higher expenditure. It saved more total, but it wasn't nearly as cost effective on a per kilowatt basis. So it's just, I think the moral of the story is you can save more money by replacing your outdated appliances than by putting in a PV system. Not that a PV system isn't a good thing to do, it's just, it wouldn't be the first thing you'd do. So 3 years ago, we worked with Solar Plexus, a solar company in town, to put up this PV system. It's a 2 kilowatt system. The original cost for the whole thing was $18,000. We got a $6,000 grant from the utility to do it, and then we got about $4,500 in tax credits. So our out-of-pocket cost was about $7,500. It saves us about $350 a year. It's reduced our electric consumption considerably. We use about 15% of what an average house would use. But electricity is by and large so cheap that it doesn't save a lot of money. So at $350 a year, we'll probably pay back that $7,500 investment, in 23 years or so. So it's not a real quick turnaround. We think it was the right thing to do, and we're happy to have it, but there are other things that would be more cost effective to do first. Though in our house, I think we've done most of those. I mean, there are a couple of things that argue for putting them in now or in the near future. You know, one is the cost of the systems are going down, and there are actually, you know, this is a silicon-based system, but there are other systems that are being built that are even more cheaper than this on a per kilowatt basis. The other thing that's going on is that electricity continues to go up. It's going to get more and more expensive. So both of those things argue for going ahead and putting it in and taking advantage of the benefits. What this shows is the blue line is our average electricity use on a monthly basis up until the point that we got the photovoltaic system. And the red line is what the average, what we've paid for since we've got the photovoltaic system. And you can see that, you know, beginning in June or July, we stopped paying for electricity altogether except for the service fee. And we're generating enough and banking enough electricity that we're able to go into October and into November, all the way into October without paying anything, because we're using those kilowatts that we generated back in July and August. And then back by December, we're kind of back to paying for everything that we consume. But again, this difference between the blue line and the red line is how much is being generated by the solar, even in December, you know, even middle of winter. If you generate more electricity than you use, you end up losing that. You're giving it to the utility. So what that is an incentive to not size your system bigger than what you would use. Because if you do, you're paying for that system, but you're not going to get the benefit of some of the electricity that it generates. And you know, that's a policy issue that may change at some point in time. For us, we didn't have any more room to put collectors on our roof. I mean, we maxed out what we could do, and you know, we're able to satisfy, you know, better than 2/3 of our electricity use using our photovoltaic system. You know, it'd be nice to be at 100%, but you know, that's okay. The other big thing I think that's, you know, worth kind of thinking about as far as conservation is just your own behavior. You know, we figured out a couple of years ago that we really didn't need to use the dryer. You know, if you have a good drying rack and some hangers, with the high efficiency washers that spin most of the water out, we're able to dry virtually everything, even in December or January, in 24 hours in our house just by hanging it up. So we have a nice dryer, but we use it maybe 2 or 3 times a year at this point. You know, the other things are just, you know, have a computerized thermostat that you can program so that it turns things down in the night. You don't have to remember to do that. Just all those little things, and they add up, and you can really reduce the amount of energy used, what you have to pay for it, and your carbon footprint. So it's pretty wise kind of thing, I think.
The primary thing about this home is the scale. It's scaled down. I mean, this is a remodel on an existing foundation, and the idea was to be energy efficient, we needed to just reduce the amount of space that we were going to consume, and also use less materials, and then also it costs less to heat it and to cool it. So these floors were original floors here, and then we picked them up and had them, you know, of course, when we were ready, then we put them back down and refinished them. So we just recycled that product. We rearranged some of the configuration of the rooms. This room and the dining room behind me are done in, the plaster is American clay, which is a naturally pigmented product that just goes on like plaster, several coats of it. And you can do it right over sheetrock. the paint here, and then in the other rooms is a clay-based paint. So there's no VOCs or volatile organic chemicals that are going to push any gases off. So that with the marmoleum in the floors in this room are all done with the eye to keep chemicals out of the environment that we would normally breathe. The other thing you can see in this room is that, and you'll see it throughout the house, these are window quilts that are made by a woman local here in town. She's called Cozy Curtains is the name of her business. And these are 7 layers of recycled material and others that acts as an insulating panel. And so what you do is, in the wintertime, you just drop the curtain to keep the cold air out. So in the wintertime, we just drop like this, and it really does make quite a difference for keeping the cold coming out. And then also, if you have a window like upstairs where it faces the south, and you get the heavy sun in the summertime, you just use it the same way, but you just block the heat from coming in. Okay. This floor is made to be wheelchair accessible all throughout on this whole level. That was just by design. So small kitchen. Here we're using small appliances. This is a Danish refrigerator. Uses very little electricity. Small 24-inch gas stove. We don't have any 220. We just have 120-volt system in the house. There's nothing that requires 220. Our clothes dryer is gas. It's not electric. This is the dishwasher, just a real small, simple, German-made, very efficient, wonderful little machine. We also have, which you can't see from inside the house, and that's why it's on that sheet, telling about things that it's not visible. We use a solar hot water heater, which takes the UV rays from the sun and heats glycol, which circulates through a race, and it goes to the tank upstairs where it is backed up with a gas-powered, on-demand water heater, a tankless water heater. So in a day like today, we'll take all of our hot water needs from the sun. So we don't use any gas then to heat our hot water. So typically in the evening then we would run the dishwasher because we've got all this made up. If you want to run some clothes in the evening, a good time to run them to the washing machine. If you want to take a shower in the evening, all that's free hot water. So let's see, in here, again, more space-saving kinds of things. We had to figure out how do we get more storage than you would get in a normal house. So we had wood benches that are built in here. These are just, storage benches, and they're made out of local fir. It was grown and milled in Ovando, and a local craftsman, made those for us. So this is master bedroom. Again, space-saving. Queen-size bed. It's a flying bed. It just folds up every night when we get out of it. We don't have to make it. We just fold it up into the wall. It's really nice. But you see, we have this other space, so we were set up so that if you want to create an office in here, a daytime office, you could do that. We can just walk on around. Sliding doors here, just panel doors, rice paper. So, gas clothes dryer, really nice. Just wouldn't be without it. Barrier-free showers. So there's no barrier here on the floor. Just so you can get in wheelchair accessible when we get older, and we need something like this. This is the way we'll do it.
Tub, just the shower, right?
Yep.
That's very.
And continues right on around again, and then I'll just. This is the. Russ's product is the heat recovery ventilation system, and this is the master control here. So I just have it now just set on a variable cycle. It'll turn on and off and on and off. Here is just a constant run, and then if you had smoking odors from cooking or from want to run from the shower, if you had a lot of steam or something, you just kick it up to the high level, and it cycles it on out. But this just provides a constant supply of fresh air, and it recovers 80% of the energy as it exchanges for fresh air coming in. Okay, let's go upstairs. So again, all those rooms are done in a clay-based paint. These stairs are an example of recycled wood from buildings that were reclaimed by Heritage Timber. We were really happy to find, some beautiful wood.
Looks like fur.
It is fur, yeah. It's really old fur. So up here again, the marmoleum floors, cork floors, cork like in the kitchen. These are made from all natural product. It's the old, linoleum, original linoleum that was made out of linseed oils and products. This is our guest room. This is the other flying bed for a guest bed. Again, we just fold it up when guests aren't here, and it's just a full-size mattress. It's really comfortable.
Where does the hardware come from for those?
There's a company that I found now named Sico, S-I-C-O, and I think they do business here in Montana called Flying Beds of Montana. But Sico is they supply a lot of hotels, which is how I found it originally. Really high quality. This is their European model, which is real simple. The one downstairs actually has big pistons that, that you can adjust to pull it up and down real easily. So
when that comes down, does it lay right on the floor? Or
no, the feet, well, on this one I can show you because I don't have it made up, I'm pretty sure. This one just has then a foot that comes down.
It sure makes so much sense. You don't need a great big room dedicated to just...
Yeah, and they make it so it'll hinge to the side too, so it doesn't have to hinge off the top, off the end of it. So if you wanted to hinge it, like if you had a room and you need to just hinge it and fold down this way, it'll do that as well.
Sure.
Okay, the heat recovery ventilation system is back in underneath that knee wall, and it just sits back there. And of course, the ductwork is hooked up. This is one of the places that it should be blowing out of that one, and then it's just the whole house is hooked up together. And again, this is just another guest shower. This is really the only door in the house, and it's a barrier-free shower there as well.
Are these floors actually just like 12-inch squares, or is it a sheet?
No, they're let's see if we can figure it out. They're about this long and this wide, and it's called the click format. They just click together.
Okay.
So if you looked it up online, you just look for marmoleum click format, they call it.
I like that. I like the floors.
It's wonderful.
Hard to see the joints.
Yeah, it's hard to see the joints, and it's so easy to care for. I've got a product downstairs I can show you for, since they're an organic product, there's a carnauba wax, and it's called Floor Milk. It's just a commercial product, but I just dilute that, and then I spray it on and clean with a rag and wipe it over, and it just the floors just get this kind of glow to them, and they just have this natural sort of look. So you don't use any, caustic
Wax
cleaners
or
or any
anything.
wax or caustic cleaners or anything.
Yeah.
Pretty easy.
Sure.
So here, this is I described the coil that's coming off. So the coils come into this tank, this blue tank, and that's the heat exchange tank for the domestic hot water. And then this other unit, the white unit, is the on-demand water heater, the tankless water heater. So it kicks in. So what is it saying here on this dial? What temperature have we got today? That's what we're getting from the sun right now. 90, 100 degrees? Where are we?
Almost 120.
120. So that's what's coming off the roof right now is 120 degree heat from the sun.
What would you say, how much of a percentage of your hot water does that supply during the winter, maybe?
Well, if we use it, if I talked about it, when we use the water, when you ask for hot water, at 10 degrees with a light filtered sun outside in the wintertime, you'll be making 90 degree water here.
Okay, so that takes a big chunk of it.
Yeah.
Yeah.
So you don't have to heat it from 45 or 50 or whatever it is, at the municipal water supply. So you've got 40 degrees already on top of that, and those are the easy ones just to put it up there. So you're just taking it up to that next level of where you want it. And when you take a shower or when you turn on the washing machine downstairs, and when your cycle kicks on and asks for hot water, it makes hot water from here.
Okay.
But it's just using preheated water. Around the corner here, if you want to just look inside, is the battery system and the inverter for the PV system, where we bring in our power from the photovoltaic panels, and it's part of a net metering system also.
So there's no basement in this house?
No basement. We made just a plenum. We dug out underneath, because it was a real old house. We dug out 30 inches below and took the gravel out, and then created just a dead air space and insulated all the way around, both sides, inside and out of the foundation. So that just stays at a constant 60 degrees down there. And then, of course, the heating is radiant floor heating. And so everything just stays at a constant temperature. Summer temperature, winter temperature is pretty much the same in this house.
How did you accomplish the radiant floor? Is that the staple up tubing underneath?
Yeah, it's a staple up tubing underneath, yeah. And we have 3 zones.
Okay.
Yeah. So that's pretty much all of it, unless you have some other... Oh, I know. Well, let's just walk to this window. I can show you something else that's fairly significant about the house. This roofing product across the way there is called EcoShake, and it's made from ground up plastic milk bottles and waste construction fiber. So it's 2 items that normally end up in a landfill, and they make these shakes out of it. They're just like a rubber spatula. And they have a 50-year guarantee on them. And it's the finest product. I mean, one, because it's very durable. They use it in Oklahoma where they have tornadoes and things. It stays down. And also you're using out of materials that are totally recyclable. It doesn't, I mean, it requires some energy, I'm sure, for the heat to produce them, but you don't have to, have any Saudi oil, for petroleum-based, shingles, asphalt shingles that last at the most 20 years. I mean, they're 30-year rated, but there's nothing left after 30 years. And these show every sign of just continuing forever. I mean, we don't know. Nobody's had them for 50 years yet, but it's a wonderful product. And we used it on a house in Helena, and then, of course, brought it here to use.
From a distance, they resemble like a concrete tile.
Yeah, they're very nice. They're very nice. And we had we had to pay the shipping and everything, but we brought in a semi-load because we did 4 buildings. We did the 2 houses and the 2 garages all at the same time.
Can you tell us a little bit about the windows?
Well, the windows are just a double E, double glaze, low E glass, and they're not the top of the line, but they when we did the blow door test with Russ, I mean, they stood up really fine. There's no leakage or no infiltration through the windows at all, even with those pressures that we created.
Wow, that's good.
Yeah, they're really nice. We just get them locally through Boyce Lumber.
And these are some more of the...
Yeah.
Those are really
Is this like a magnetic
That's a magnetic strip. That some of them we learned about. We did them downstairs first, and then learned that as we drop them, you can just press that magnetic strip right to the press, and it's built into the fabric on the others. So
It seems like that
it seals as it seals better, then you're better off.
Right.
But even if they don't seal, I mean, just even dropping that over there, there's a huge temperature differential because just the glass, is just a big space for heat to escape. And we use this one in the summertime just to drop it because of the heat coming in. We have the little house next door, and it has the same sort of a dormer window, and we put that up in there and also in the kitchen on the other house.
Mm.
So this is the shoe bench, which is a feature that I wanted to create so that people would take their shoes off when they came in the door. We use scrap wood from the floor. The floor is made from the former Bonner Mill site. It was a building there that was taken apart and remilled into flooring. And then we have the scraps left over, and they have some what you consider beautiful flaws that you can't use for flooring, so we decided we could make other things out of them. And I also wanted this piece to look a little tiny bit like a surfboard shape and have an Asian look, because the whole house is designed to look a little bit Asian, a little bit Scandinavian, and a little bit Montanan. And creative. If you look this way, you can kind of see that I like color accents and wanted to make it feel like a playful place. Some more of the recycled materials in the house are this countertop. This area was opened up. It used to be kind of a closed box, and I ended up, when I saw the house originally, I thought that would be the easiest thing to do immediately, would be to create an open floor plan. And so we took this wall out and put this counter in, and with that flow through, it has become a really great place for people to hang out. And this wood is scraps from the floor. The kitchen is from Home Resource. I'm sorry, the sink is from Home Resource. The stone that is creating the counter around the stove is also Home Resource. Those are scrap pieces of granite from the Sierras, which was a favorite hiking place of mine, and I would never want to do any actual mining there of any kind, but the idea of being able to salvage scrap and have it in the house, and also have that reminder of that area was really wonderful. Plus, because it was from Home Resource and it was recycled material, it was very inexpensive. It was $35 for all of this countertop. And then this countertop also is scrap from the floor. There'd be these small pieces where there'd be some area that we could use, and so we kind of had that. One of the things about using reclaimed materials, you save money on the material cost, but the labor cost can go up because you end up getting it's like recycling anything. It takes more time, and so that was, if you have the time to do it, then you can still save money. But if other people are doing it for you, then that's going to end up costing. And this also was built out of some more of the same wood. That was not, some of that was recycled, some of it was, it's all part of the Bonner Mill wood, but some of it I actually just bought from Heritage Timber and to kind of finish off the kitchen. Then this is a kind of fun piece. The robin keeps wanting to build a nest there. I don't know if it's gonna end up. It's like, can we live in harmony with nature? Right this minute, I'm conducting an experiment. I got this range hood from Home Resource, and I want to make it into a fountain. And so I'm about to plug it in and see if it's going to work. First, get everything wet, just for fun. And there's a pan under here, a shower pan that's underneath, that's catching water, hopefully, and going to return the water to the surface. Okay, keep your fingers crossed. Plug it in. Well, that part's working. It's not attractive. might need a little. I'm going to put some stones in here to cover that up, some Japanese stones. But we have like a little. Hey, see? Look at that. Yay! It's looking good. All right, so that you're here to see the birth of the fountain. The backyard shows a couple different things that relate to recycling. Home Resource has a great selection of windows and doors, like these French doors here. These doors, the general contractor who helped me with the house told me cost over $1,000. They're really in great shape, and they were $175 at Home Resource. It didn't take too long to frame them and put them in. It was actually a really great thing to do to improve the house, and they're double insulated. And then I excavated this area here to make the the basement be able to support 2 bedrooms and a bathroom. So this was all subterranean before, and those windows are all home resource windows. That was all framed in one day, and ended up being really pretty inexpensive way to upgrade the house. The windows themselves were about $35 per for the single frame. And then my friend Donna Thomas is helping me put landscaping in that's all native plant, and we're working on that. This is the beginning. Hi there, welcome.
Thank you.
Yeah. And let's see. There's kind of fun thing up at the top. There's a hammock made out of hoses. That was part of the spontaneous. If you want to check this out, I don't know. But you have socks on, so let's see what you guys. Yeah. But it's kind of fun. You can lay in the hammock right up at the top. It was made during Spontaneous Construction Festival last year, and I competed with some friends, so it's a fun reminder of that day, which was really great, colorful day, and now we have a hammock. And yeah, and I don't know what else Home Resource would have done with all those colorful hoses and wires. So, let's see. So how about if we go downstairs? He's doing a little filming for MCAT.
No, okay.
But yeah.
I didn't even look.
Yeah, yeah. Please feel free to join the tour,
Okay, I will.
or yeah. Okay. Okay. I'm going to bring this box downstairs too. So the house initially had a Berber carpet that had been in the house since 1968 when the house was built, and the carpet was actually really cool. I loved the carpet, but I couldn't get it clean. And so that's when we started taking it up and seeing what materials we could use to floor the house. And so there's a bit of it. The bit of the house is done with bamboo, and then salvaged carpeting. And then this bathroom is. Let me do this because it looks prettier that way. This bathroom is almost entirely Home Resource materials. This flooring is from Home Resource. Originally, these tiles cost about $7 per, and these were 50 cents each, but we had to scrape off the back. They were a real find, but they were a little bit of work. The toilet seat cover, the faucet, the windows. This tile, this was made at Home Resource's revamp shop by a very skilled welding person named Mike, who's part of the Back to Work program that the welding that the revamp shop has. This piece is this was an 8-foot screen, and I've seen it in Dwell magazine. It's a pretty famous architect uses this occasionally, and anyway, so I used a section of it for here, and then it's upstairs too, and then the cupboard doors are made from it too. We just took them off and applied them. And I had this idea for this bathroom to make it look a little bit Asian, and then since it's set down, the idea was that you could open the windows and have a little bit of nature and almost feel like you're outside taking a bath during the warmer. Yeah, yeah. Eventually I want to put a few like grasses and reed type things in there, so that'll be fun. And like this is some more of that recycled wood from Gary at Heritage Timber. We tried to pick pieces that had some really fun flaws in them or gorgeous sculptural elements to kind of highlight, and even the floor around spots that we kind of wanted to highlight the gnarly bits. So this room was a semi-finished basement room without a window in it, really, and now it's a nice framed space. It has there's an efficiency boiler behind the wall over there, which you can't tell, but this room is really toasty in the wintertime because it's right next to it. And this desk setup is my housemate Scott, who's a photographer, you can see his stuff on the walls. He just got these at Home Resource and put them together, and I love. And these chairs are from Facility Services sale over on campus, so it's kind of fun to have some library chairs too. Yeah. So this room, the headboard is made from recycled ponderosa. This dresser was actually, I found this dresser covered with mud and grass in the front of somebody's yard. And basically they had a sign that said, "Put money in mailbox, take away." And it was in really bad shape. And it also was kind of funky because some of the legs were broken off, and it had a weird big piece that was on top. It's a walnut dresser. So I took it and refinished it, and it had all these chips. It's actually not solid here. These are like little laminate walnut fronts. But I kind of patched it up and refinished it, and so that was fun. And this is a door from Home Resource. And over here we have a bathroom countertop and shelving made from more recycled large ponderosa, wide ponderosa pieces, and that was really fun to be able to figure out because it has a little bit of an Asian look to it, and also it was an inexpensive solution, and it was fun to design and use the recycled materials, so that was neat to do. And then the baskets are made, there's a company that is, you can buy at TJ Maxx or Ross, and this material here is called hyacinth. This is hyacinth. It helps clean sewage, water that contains sewage. Hyacinth is great vacuum cleaner for getting the toxins out, and it grows voraciously, and they're using it now to do all this woven furniture, which is under eco label. So if you go to Ross or TJ Maxx, they often have the stuff there, and so I tried to use a bunch of that. Yeah, so, and the lilacs are from here. Okay, yeah. Let's see, what else can I show? Oh, the windows are from Home Resource. And wanted to try and do some local gardening too, so we put in the boxes, and the boxes are all wood from Home Resource, scavenged wood. And the little, I don't know if the camera can, yeah, I guess the camera can take this in. The little stair steps made out of tree stumps are from the next door neighbor who was taking down a couple trees. I said, can we just take those and use them over here, and we'll cut them up. And they said, yeah. So that's where they came from. And they are fun. I'm waiting for the grass to come in and make it look like little trolls or fairies live here. So. The doorknobs too, and all this. Oh, this is made from Home Resource. This was made at the revamp shop. I wanted to look a little bit like barn doors, and these handles came from Home Resource, and so did this one. It was fun to basically raid the place and get lots of materials. Yeah, all the door handles downstairs are all Home Resource too. Hi.
Hi, my name's Ryan Alter, and I appreciate you coming on our tour today. I'm the homeowner and actually the business owner as well for this project and house. I'm the owner of Alter Enterprise, and we do energy monitoring systems for mostly commercial and sometimes residential. This house is where we kind of test things out on and try out different products to see how much energy they actually save in the real world versus what it says on the back of the carton. One of the features we have on the inside of the house is dimmable LED lighting on the ceiling, which is about 7 watts of power consumed versus 25 with your standard like compact fluorescent. And so we have seen a little bit of energy savings with those. Most of the rest of the house is compact fluorescence. Another feature that isn't necessarily particularly energy related, electricity, is our flooring that we put in throughout the house. And it's north slope sustainable wood. And this flooring was initially designed off of a grant with the Forest Service to check and see about the long-term viability of small diameter larch being used as flooring. And I can tell you that so far we've been extremely happy with it and have it throughout the whole house. It's been a very stable flooring product. It hasn't moved around on us a lot, which was one of the concerns initially. And so it's just another thing that we really enjoy about the house, and it's a local company and the product's made here locally. The plug-in hybrid has a kit in it in which we installed. I run a company called Alter Enterprise, and we actually install these conversion kits here locally in Missoula. And the conversion kit is kind of like an extra battery for your Prius, like you would have an extra battery for your cell phone. It allows you to do more. So in this case, it allows the Prius to go 30 miles in range at 34 miles per hour or less on pure electricity mode. And so the cost savings is actually quite significant. I put fuel in the car during my normal commute probably about once every month and a half, and it costs 47 cents to charge this system off the grid with power. And so it's one of the things that we've done to offset our carbon footprint, because transportation, anybody that kind of studies carbon and things like that will find that the transportation is a large part of that. Another thing we actually did is to go a little bit above and beyond, is we actually charge this car off of the solar panels that are on the roof in the back. On the outside of the house, one of the things that we did is we decided that we needed to re-side the house. And so we added insulation behind this siding, and then we used Bad Goat products, which is sustainably harvested wood, for our batten board on the lower part of the house, and Cedar Saver shingles for the top part. The Cedar Savers are a product that was manufactured by Home Resource, and they're basically the cut-off scrap ends of the industrial cedar processes that are out there on the market. So they buy those scraps and then resaw them into the shingles. And so that's where the siding and the shingles, and Lucas will talk about the energy savings from the insulation that we added behind the siding. So what we have here is our home energy monitoring system. And this system will actually tell us where the power from the solar panels as well as the grid is going real time in our house right now. And so you can see over the past day, over the past hour, and over the past month, what has been the largest consumers of power, whether that be electricity, natural gas, and we even track hot water usage to see where our big usages are in the house. And this helps people like Lucas and Allie, when they come in to do an energy audit, to say, okay, well, here's some possible savings. And so always start with your biggest consumptions first. And so this is how we can judge where our big consumptions are. And then we can say, okay, well, here's where our cost savings measures will be most effective. Here's where we want to spend our dollars first at. And so I'll let Lucas and Allie chat about some of the energy monitoring, how that's played into their blower door testing and their energy audit that they did on the house.
My name is Lucas Dupuy. I'm with Adapt Design Build in Missoula, and We're participating with Ryan on this project because we actually had a really unique opportunity in this case where we could compare a software model for energy usage to a real-life situation with Ryan's energy monitoring system. So what we did is we used a software model called REMrate to generate a hypothetical energy usage for the house as it was originally built in 1986. And then we put into the software model the improvements that have been implemented on the house. For example, the extra insulation and double pane windows. That was about a 10% improvement in energy usage and was backed up by Ryan's utility bills, which was a nice comparison. The next thing that Ryan did is he put this 2 kilowatt PV array on the house, and the software predicted that would lower the overall energy usage of the house about 20%, although it doesn't do much for heating or cooling costs because, well, there is no cooling on this house, but the heating uses natural gas. However, it was a significant reduction in the energy usage for the house overall. So using that historical data, we then proceeded to say, what if Ryan wants to go further? So we modeled what would happen if he replaced his 1986, circa 1986 hot water heater and furnace with new high efficiency models. That predicts another 20% savings, although primarily in the area of natural gas usage. So that has Ryan with solar panels and a new furnace and hot water heater and energy improvements to the house, saving about 44% of the energy, or is a 44% decrease in the energy used compared to his 1986 house. Then we went one step further, which would be for Ryan to implement a deep energy retrofit on the house. A deep energy retrofit is a fairly major remodel of the house that would make the house significantly tighter in the range of under 2 air changes per hour and add a significant amount of insulation and mechanical equipment to the house. However, the deep energy retrofit would predict Ryan to save something in the range of 65% of energy. So that would be a major investment, but it goes to show that the software, although not perfect, can be a fairly good prediction of how much energy you'll save when you implement energy conservation measures on the house.
Hi there, I'm Allie Depew with Adapt Design Build. We are a business in Missoula, Montana that focuses on energy retrofits and extremely efficient new construction. We set up this great blower door test in Ryan and Stephanie's home. For those of you who don't know what a blower door test is, what it does is it tests the pressure in the house with reference to outside, and it gives us a little sneak peek at what's happening, where leaks are coming into a house. So imagine that there's a terrible windstorm outside and it is hitting all sides of your house, 20-mile-per-hour winds. This is what this does without actually having to have that windstorm come upon your house. It pushes the leaks, it pushes the air, pulls the air into the house, and lets us know where's that air going, when it is cold and windy outside, wintertime in Montana, where is that heat escaping from, or where's the heat in the summertime coming in to make your house really warm. So what we do is we turn this on. It'll give us some readings on our manometer right here. We do some calculations and it'll give us a number that is an air change per hour. So when we turn this on and we depressurized Stephanie and Ryan's house, we found that their house was 7.8 air changes per hour. So if you think about it like this, 7.8 times in 1 hour, your heating system has to reheat all of the air in your house. That's quite a lot. There's quite a lot of energy that is being used in order to heat a house 7 times within 1 hour. So that's a relatively high number. Right now the building codes say that 4 air changes per hour is where they're trying to target new homes. When we design and build houses, we get them under 1 air change per hour. Some of the things that we found in Stephanie and Ryan's house, we put our blower door on and then we took our infrared camera and took a look around the house to see where it was leaking. Up here over the sink, or over the oven, there was a humongous air leak up there. And I said, Ryan, what's going on up there? Why is it leaking? And he said, gosh, you know, a long time ago, when we sort of did some remodeling in here, we took out our microwave. I said, okay, well, that's where the vent used to go. And so right now there's just an open hole in our roof that just goes outside where the vent of the microwave used to be. I said, okay, Ryan, well, that's definitely going to be a huge place that we need to fix. Cam lights right up here are really leaky. They just go up. What they do is they compress insulation. They make it so insulation can't be there. They provide a way for air to just come straight into your house. That was a pretty leaky cam light. Underneath the windowsills of this house, when they put the new windows in, it's not a tight seal, and so we could actually feel with our hands the air being pulled into the house, and you could feel the draft, pretty strong draft underneath those windows when we had the house depressurized. Another spot which I suspect is relatively adds to the leakiness of their house is in their utility room, where there is the furnace and the water heater, and they're originals from 1986. They're pretty inefficient models, and one of the things that we recommend for Ryan and Stephanie to do is, along with some air sealing, is to upgrade those. They're open combustion appliances, which means that there is an air tube, a pipe that comes into the room, and it provides air for those appliances in order for them to work. What that does is just let air into the room, into the basement, into the house without any break between the rest of the house and that room. So in a case like this, we would recommend upgrading both the water heater and the furnace. In other cases, in other scenarios, when maybe that's not an option financially, or it's a newer hot water heater or a newer furnace, what we would recommend doing is creating a separate room for those and sealing that off from the rest of the house, so that you don't have the air coming in and cooling off the rest of the house in the wintertime. But that's sort of what we do, and their blower door test, and how we help Ryan and Stephanie.